All right, so for this one, we're rationalizing the denominator. And it looks a little bit like division, but again, it won't be division because it'll actually say rationalize the denominator. So that way you know that's separate for what's going on for what we're doing today. This is, for queuing up your notes, this is lesson number 22. Today is May 7th, and today's Friday. Okay. All right, and there's two types of these that we're going to do. Type one, actually, we'll go ahead and get the easy one out of it. This is, y'all actually, we've done this before. Now, it's been a while, and some people have forgotten. So it may take a minute to go back and do this. But this is where the first type we're going to look at is where we have just a single term denominator. And there's actually, on this one, there's even two types inside this. Because the first one we're going to do is we're going to do square roots. And this is the one that we've done. Now, it's probably been a while since we've done these. So it may be one of those that when you first look at it, you know, you may not quite remember it. But let's say you had like 4 over the square root of 3. All right, now flash way back when we were doing all the trig stuff and we had our trig worksheets and doing everything. And if you remember, there was a shortcut when we were doing secant and cosecant and cotangent with square roots. Anybody remember what the shortcut was to fix this one to where you basically would rationalize this thing? Okay. Yeah, you could square the bottom on that one and do that one. The shortcut was, and let's kind of get through this and see if y'all remember what it was, that we would take the problem we've got here. We would take the 4 over square root of 3. We would move the square root of 3 from the bottom to the top, and then take the square root off the bottom. Is that ringing a bell? Is that starting to look a little bit familiar maybe? But on first block, when we went through this one, they were like, at first, they were like, oh, yeah, I remember doing that now. So if you had, 5 over the square root of 7, the 5 is going to stay on top. You're going to move the square root of 7 from the bottom to the top. On the bottom, you take the square off and leave it just as the 7. So, that seem familiar? Everybody? Is that at least a little bit kind of sort of familiar maybe? Hopefully a little bit. The only ones now where you might have to do a little bit of work is you might have one like this where you have like 8 over the square root of 6. So if you move the square root of 6 from the bottom to the top, on the bottom you would just leave the 6. For that one, you've got, if you look at the fraction part of it here, you've got the 8 over 6. There you could divide both of these by 2. So you could make this one 4 square root of 6 over 3. Okay, now here technically, and this is what you don't have to write this down because we're going to go through the shortcut on this. What you're technically supposed to do here was if you had 5 square root of 7, we wind up multiplying by the same thing that was in the denominator. Again, you don't have to write this down because this is what we did. Then on the bottom, if you did 7 times 7, that made it the square root of 49. And then you did the square root of 49 and made it 7. So that was the technical way we were supposed to do it. But we said, all right, really what we're doing is we're just moving the square root from the bottom to the top because we're multiplying it. And on the bottom, when we multiply by square root of 7, we get 7. So we were kind of squaring the bottom, but not necessarily squaring the top. So we were kind of just multiplying the top and bottom by square root of 7. Okay, so that was what we've kind of done in the past. So hopefully you're looking at that going, okay, maybe it's flashing back and coming back to you for those. Here's the second type. This is the one that gets a little bit tougher. If it's anything other than the square root, if this is third root or fourth root or fifth root or sixth root or something like that, it's a little bit different for what you've got to do for this one. It's not just we're gonna take this shortcut here where we move the square root from the bottom to the top. We're gonna do the same thing on this one, but it's gonna be a little bit different. And I've got an explanation on this one. I don't know. It's not the best. I don't really like this explanation part of it. because it's a lot of times we'll get the explanation and people still look at it and they go, all right, I don't get it. So, all right, so here's what we're going to do. We're going to kind of cheat on this one a little bit. I'm just going to show you because it's a lot easier to show you on this one than it is to actually kind of write it out and tell you what you're going to do. Okay, so if its root's bigger than 2, so now we're looking at like the 7th root. And it doesn't matter how big the number is, what the root is, because it's still the same setup, and we'll show you 2 or 3, because once you get the hang of this, it's really okay. Okay, so we're going to do like we did on the first part here. We're going to take the original problem that we had. We're going to move this, instead of a square root, we're going to move the 7th root now to the top, but we're not going to put this second power here. We're going to show you what we're going to do here for this one. And on the bottom, just like when we did the square roots up here, we're going to take the square root off in this case. But to get rid of the square root here, this thing has to be x to the 7th power. That if we're going to cancel this thing off, let me just put this over on the side, we need this thing to be the 7th root and the 7th power. That way this stuff will cancel, and we can just get the x that would be here. And that's what we're trying to do with the rationalizing part, is we want this square root or 7th root or whatever this thing is gone, so it's just a number or just a variable on the bottom. All right, now here's what we're going to do on this. Here's the trick for this one. To figure out what we need to do is that we're going to take these two numbers and you're going to subtract. 7 minus 2 is 5, and when you subtract, you put that number inside right here. Okay, now, and kind of like we did on the last one, you don't have to write this down, but let me just show you technically what we're doing on this one so you can kind of see what it is that's happening here. That for a problem like this one, we're still going to do the same thing. We've got 10 over, again, you don't have to write this down, just kind of watch. We've got 10 over the x root of 7. We're making this thing so that this becomes the 7th root of x to the 7th so that they cancel. And we can just get x on the bottom. Okay, so here's what you have to do. If this thing is already x squared, we've got 2 x's. To get this thing to cancel, we've got to get 7. So what we're going to do is we're going to multiply in so that we now have 5 more x's. Because we've got 2 here, we've got 5 here, that'll get us to the 7. And whatever you multiply on the bottom, you have to multiply on the top. So that's technically what we're doing in this case. But again, the shortcut is just move the square root, or in this case, the 7th root, from the bottom to the top. On the bottom, you're going to get rid of everything and give me just the variable that you have that's going there. And to get this part going here, you're going to subtract these two numbers, and that tells you what power to put in there. Because you're going to need that many x's on the bottom to get it to cancel. And whatever you do on the bottom, again, you've got to do the same thing that's on the top too. Okay. And again, we can just make up all kinds of random numbers on this one. It could be that it's 8 over the 10th root of b to the 3rd. Okay, so it's going to be the 10th root of b. And again, to get the power that's going to be here is you're just going to subtract this root and this index. So 10 minus 3 is 7. So we're going to put a 7 right there. And then if we can get this to be b to the 7th, then those two things will cancel out. We'll get just a b on the bottom. And this could be even that this might even be, 4x over the 9th root of t to the 6th or something like that. If you have more variables, don't worry about it, because again, all you're doing is you're just worried about what's on the bottom. So for this one, we're going to move this 9th root from the bottom to the top. And because to get this to cancel, we've got 6, we've got to get it to 9, so we've got to add 3 t's on the bottom. If we add 3 t's on the bottom, we're going to have 3 on the top. So we're just subtracting these two numbers that's here. Okay. And if we do that on the bottom, again, those will cancel once we make that 9 and 9, so it'll leave us a t on the bottom. Okay, so square roots are easy because it's just the one number. Because, and again, if you kind of go back to that one, technically what we're doing is that we're doing the same thing on this one. This is the square root. If we're doing like 5 over this squared, well, this one's the square root, so we need 2 of them. When we multiply this in, well, 49 is the same thing as 7 squared, so they would cancel each other out and we get this one. It's just, now it's more obvious because this is the 10th root, the 9th root, or the 4th root, or whatever else it's going to be. The only one that might have just a little bit of work to it is you may have something like this. You may have like 6 over the 4th root of 2. Instead of giving me variables, it may just be all numbers. And sometimes this one gets a little sneaky because people are used to seeing the x's with the variables or with the exponents. This one's just a number, so technically this is 2 to the first power. So when you subtract 4 minus 1, that makes that 2 to the third. And on the bottom, again, that would cancel each other out once we subtract those, and then we'll make that a 2. Okay, now, and sometimes, depending on the numbers, it might stay okay. In this case, you could actually divide 6 and 2. Divide them both by 2, make it 3 over 1. Well, if it's over 1, it doesn't really do anything. So it's 3 times the 4th root of 2 to the third. And they might leave it as 2 to the third. They might also make you multiply that out. Oh, hang on. That's not right. Oh, messing that one up. So if you do 2 times 2 times 2, that would be 8. So they could go this route, or they might do something like that. They probably will let you do either one, so probably either one would be okay. I would try that one first. If they tell you, well, the answer is correct, but you don't have it in simplified form, well, then you just take that and then go here so that it is in simplified form. Okay, so that's the 2 types. You've got or in this case, the 2 different versions of the single term denominator. You've got square roots, which we did with radicals way back, or with sine, cosine, tangent, when we did all the trig a little back then. This is one where we bump it up just a little bit, so now it's not square roots, it's 10th roots or 7th roots or 8th roots or something like that. But again, it's a shortcut because you just subtract these 2 exponents and put that number up there. Okay, second type, type 2. This is a 2-term denominator. And the trick on this one is, and actually it's kind of good in a way, because there's really not anything new in this one, because when it tells you to rationalize a 2-term denominator, rationalize, there we go, you're actually not doing any, you're really just going to multiply. So all that rationalizing is, it's just an extension of multiplication, because it's really just a multiplication problem. You just have a certain specific thing that you have to do. So, okay, so for a 2-term denominator, it's really just multiplication, because here's what you're going to do. You're going to multiply the numerator and the denominator by the conjugate of the denominator. Okay, if you remember a couple of days ago, I think we were doing conjugates because when we went through and did the multiplication, we said the conjugate is where you just have to where was our problem here? Trying to find it. Was it there? Well, where it was. We were doing something where we're multiplying by the conjugates. Can't find the day now. Anyway, that it's just changing the sign, the plus minus sign. That, if you have square root of 3 minus 5, then the conjugate of that becomes square root of 3 plus 5. Okay, so to get the conjugate, that's all you do. Just change the sign of the middle number that's in between both of the signs, and then you multiply by that one. All right, so for example 1. All right, so let's say we've got 2 over square root of 3 plus 1. Okay, so all we're going to do is we're going to take the original problem that we've got, we're going to multiply by square root of 3 minus 1. And whatever you do on the bottom, you have to do the same thing on the top. Okay, now here's the catch. Here's the one little thing that you've got to remember when you do this. If you have 2 terms in here, there's not going to be parentheses here. You've got to think that there's actually parentheses around that one. So anytime you see a plus or a minus sign in between terms, you've got to go ahead and put parentheses around that one because it's not going to be given. You just got to know to do that to make this thing work out. Okay, on the bottom part. Now, the reason we did this is that the other day we said if we do the conjugate on this one, it's a full method shortcut. So really it's just the first times the first and the last times the last. So that one you get to do the flush shortcut because it's just first times first and last times last. The O and the I cancel each other out because of how this thing is set up. So all we're going to do for this one is we're going to do square root of 3 times square root of 3. And then positive 1 times negative 1. So there's your first times your first and your last times your last. Okay, and every one of these 2-term rationalizing problems, it'll always be the same thing that you're going to do. It's always going to be when you get finished, it's the first times the first and then the last times the last. And whenever you do that, we've got square root of 3 times square root of 3. That is square root of 9. And it's always going to be minus that number because it's a positive times a negative. Well, square root of 9 is 3. So that's 3 minus 1. So that's over 2. Okay. Numerator, it just depends on the problem. This one's going to be fairly short because on the top, it's just 2 times the square root of 3 minus 1. And for these problems, I would say if it's just a one term on the top, don't distribute this thing out because if you get over here and bring this problem over here, so we've got it all the way out to the end so we know what we've got here. If you notice on this one, you've got the 2's on the outside. You can cancel those 2's out. So it's gone. So the final answer for this one would just be square root of 3 minus 1. Okay, and somebody's like, well, what if I do distributed property and I get like 2 square root of 3 minus 2? Well, if you put that answer in, it's going to tell you, well, your answer is correct, but you need to put it in simplest form. So it's going to tell you, hey, you've got everything correct. You've got to do some cancellations on this thing to make it work out. Okay, the only other thing that they can throw at you when we're going through these is where the numerator, instead of just being 1 term, it's going to be 2 terms. So it's going to look a lot, it's basically like the double full method type problem when we're going through these. Okay, so in this problem, we've got 2-term numerator and a 2-term denominator. But again, the key thing is it's a 2-term denominator. So you still got to multiply by the conjugate. So we're going to multiply by 2 minus 3 square root of 5 on the top and on the bottom. Okay. And again, when you start with this problem, the one thing they're not going to do is they're not going to put these in parentheses. So you've got to know that in this case, you've just got to go back and put parentheses around these. And this one, you'll basically do the same thing. Okay, and again, because these 2 things are conjugates, you basically get to do first times first and last times last. So we're going to do 2 times 2. And you may go, well, can't I just go ahead and put 4? Sure, we can go ahead and put 4 on that one. Now, this one you want to be a little bit careful because it is positive 3 times negative 3. I guess we can go ahead and multiply that. That'd be a negative 9. And then if we do 5 times 5, that's going to be square root of 25. So first times first, last times last, that gives us the shortcut we get to do there. And again, that's only because it's conjugates. And we'll go ahead and finish this thing out because it's almost done here. So that's 4 minus 9 times 5. Well, that's 4 minus 45. That's a negative 41. Okay. Good news is the bottom always goes really quick. The top part, this one's going to be a little bit longer than what we were doing before because on the top part, there is no shortcut. We are going to have to just do the full method. Okay, so going through that one, we've got 4 times 2, which is 8. We've got 4 times negative 3, which is negative 12, square root of 5. Hopefully I'll make all that fit here. We've got negative square root of 5 times 2, so that's a negative 2 square root of 5. And then we've got a negative times negative, that's a positive 3. And then if we do 5 times 5, that is the square root of 25, which is barely fit. Okay, so doing the full method here, there's what we get. Okay, and if it's a good full method problem, you've got 2 or 3 different things we can do for this one. The 8 in the front is good. There's nothing we're going to do with that, so that's just 8. The next 2 terms, though, we've got negative 12 square root of 5 minus 2 square root of 5. That's a negative 14 square root of 5. Oh, sorry, I ran off there. So we got 8 minus 14 square root of 5. And then the last piece at the end, we've got 3 times square root of 25. Well, that's 3 times 5. So that's 8 minus 14 square root of 5 plus 15. And then 8 plus 15 would make that 23 minus 14 square root of 5. Okay, and for these numbers, with 23 and 41 and 14, there's nothing they have in common because they're all odd. Well, we got 2 odds and even, so there's really nothing we can do for that one. There is no simplifying on this one, so then that would be your final answer that you get there.